Hey everyone, welcome back. And I thought I'll solve threesome today on video. I've done this problem before, but before we get to that, why not let's talk about twosome first. So this is a very famous problem, and I think it's too famous now. That's why you probably will not see this in an interview. But yeah, this one is much easier. So in terms of the input, I don't think there are duplicates in this one. So given an array of integers, return indices of two numbers where the sum is equal to target. And yeah, so you want to return the indexes of the numbers where the sum is equal to the target, right? So in this case 9. So 2 and 7 are the two numbers, and that's why we return 0 and 1, right? So if because we want to return indexes here, we don't do sort. The most optimal solution, if you have done this before, is the one that uses a hash set, right? So we use a hash set, and when we are at 2, we see if our hash set contains 7, right? If it contains 7, that means we do have a pair that adds up to 9, and we just terminate the program. Otherwise, we save the current number along with its index. So we'll save 2 and index 0, and then we'll move on to 7. Now target minus 7 is 2, so we check if 2 is in the hash set. In that case, it would be in the hash set at index 0, so we return 0 and 1, right? So that's a pretty straightforward question. Now this one, threesome, slightly complicated. First off, this input contains duplicates. So given an array of numbers, return all triplets. So it's just not one. You want to return all triplets where the sum is equal to 0. But this number, the target is like, it doesn't depend. Like, it doesn't really matter. It could be similar to this one. It could be like any other number as an input to this function. But this particular question is about finding 3 triplets where the sum is 0 and finding all triplets. But the only caveat being, we don't want to return duplicates, right? So if the same because the array contains duplicate numbers, we don't want to return the same triplet twice, right? So how do you solve this, right? So one, I think, brute force approach is you essentially just do a O(n) cube loop. So for every index you start a new iteration, so you will have 3 nested loops, and then once you find a triplet that adds up to 0, you can sort that triplet and add that to a set. So set of an array, right? So that way you can get rid of duplicates. So what I mean by that is, like, you could have like a triplet set, which is like a set on an array, and in the end you can return this, the triplet set. And to find your triplets, you would basically have 3 loops that go over the input array. It doesn't have to be sorted. It's just like just an array that you iterate over. And if the sum is 0, sum plus not sum. So num of I, num of j, and then num of k. If this is 0, you know that this is an answer. This should be part of the result, but it's just that we don't want to add this if this has been considered before, right? So what you'll do is, like, you'll say insert, you'll create a new array. So num of I, num of j, and num of k, right? And this array you would sort. Now, because this is sorted, if the triplet set already contains that result, it won't add it, right? It'll just as in, like, it'll replace whatever it has already. So this should work, but as you can see, it's very inefficient. First off, this is of n cube because of 3 loops, 3 nested for loops. and then you're doing this operation here where you are adding into the set, right? So not very efficient solution. So the optimal solution for this basically is a variation of two-pointer approach. So if you sort this array now, like if you have a sorted array, right? So let's say you have sorted nums. Now once you have an array sorted, and if you are doing, let's say, two-pointer approach, right? So you have a left pointer and you have a right pointer. Now if you take a sum of these two objects, if these two pointers, so let's say sum is sorted nums and right. Now if this sum, if this is greater than target, right. So if this sum is greater than target, what that means is that you're basically your right pointer is like too forward and you need to reduce it, right? Because the array is now sorted, whatever target sum that you're trying to achieve, in this case 0, if the sum is larger than that, you need to reduce your right so that the total sum reduces, right? Because the array is now sorted. Now if the sum is lower than the target that you are trying to achieve, you want to increase left, right? Now if both of those are not true, that means the sum is actually exactly equal to target, in which case you have the answer here. So and this only works when the array is sorted, right? Otherwise it won't work. So we can use this property to our advantage, and then you can sort of like get rid of duplicates as you're doing this. So very similar to two-sum problem, but you sort of break it. So what you have to do is you iterate over the array. So in this case we want to find triplets, right? So triplets that add up to 0. So so num1, num2 and num3, you want to add up to 0. Now if you choose one number from the array, what you want to find are two more numbers where the sum is equal to negative of the first number, right? So if you choose one number and if you are able to find two other numbers that are negative of the first number, then you have found a triplet, right? Because the sum then adds up to 0. So so that's the logic that you can use for threesome, and let me show how you can do that. So now the array is sorted, and what we are going to do is, like, we are going to iterate from 0 till the end of the array, and let's say the current number is sorted nums and index, right? So now what you want to do is, like, you want to find a pair that when it's added to current number, the whole sum, it turns out to be 0, right? That's the triplet that you want to find. For that I'll write a helper function. So write let's say I name it pair for number in sorted nums, and we want to only search within a specific boundary. So we will pass in the left, and the right would be always end of the array, so I won't pass it, and I'll take a in and out variable so that I can save my result, right? So let's declare that result variable up top. Now I'm going to find a pair for the current number that I'm on in the sorted nums, and the left would be starting at current index plus 1, and then I'll pass the result, right? So that the helper function can add triplets that it finds. So this is the basic layout of the code that I'm going to write. Now, one thing that we have to fix for is like the duplicates. We don't want the triplets, the result array to have duplicates, right? So here, like if the index is greater than 0, and if the current number is equal to the last one, we don't want to redo the calculation, right? So for the first number, we will basically go inside the loop and try to find pairs. But once we are done that, for the duplicate number, we are not going to do that. So if the current index is equal to index -1, that means this is a duplicate, right? So what I can do to make it slightly easier to read is check if the current number is equal to the last number that we did, and if it is, we're gonna skip this number, right? So now yeah, here in the end I can just straight away return results. Now in here I have the left, but I'll have to redeclare it because Swift doesn't like modifying passed in parameters. Right would be sorted nums dot count, and this loop is going to run till left is less than right, and now the sum, right? So the sum would be the passed in number plus the number at the left plus the number at the right. And now if this sum is greater than 0, this is similar to the previous logic I showed you. If it is less than 0, and finally if it is equal to 0, right? So if the sum is greater than 0, we have to reduce our right because the window is like too large. If it's less than 0, we can increment our left and try again. But now if it's exactly equal to 0, that means we have found a pair, in which case we should add that to the result. We are going to create a new array for the number, sorted numbers left and sorted numbers right. Now once we have done that, we have taken care of this particular triplet, so we should increment left and we should reduce right. Now there is a case here that we need to handle. Now because the array can have duplicates, once we have taken care of this triplet, it is possible that left and right are still pointing to equal numbers, right? In which case we don't want to consider that triplet again. So we should increment one of these pointers till left is not pointing to a number that we just found, right? So while left is less than right, that you have to do, otherwise you can go out of index, your index can go out of bounds. And if this sorted number left is equal to sorted number left -1, so we have just incremented left, right? So the new left, if it is equal to the old left, the old number that we just considered as part of our result, we want to increment left and just continue this loop, right? So this loop will terminate either when left and right sort of like go out of bounds, or we have found a new left where it's not equal to the previous value that we just considered. So that I think should be it. Finally, when it comes out of this, we have essentially considered all of the pairs that could add up to 0 when added to this number, and whenever we find the answer, we add it to this results array, right? That is an in and out variable. Yeah, I think this should work. So when we sort this, we are spending n log n time, and for every index, we are essentially doing like an internal loop here. So the time complexity is O of n square, and the space complexity is O of space complexity is O of n, because we do use this sorted array, right? Now, and in Swift anyway, the sort uses O of n space. So the space complexity is O of n, and the time is O of n square, which is much better than the n cube solution that I showed previously. So now if let's see if it compiles. Oh. Nope. What did I mess up? So I have index, now index is greater than 0, and if it is equal to last number, we are continuing. Then oh, this is not right. It should be count -1, because yeah, the last element, yeah, it'll be out of bounds otherwise. Yeah, so let me try and submit that. Yeah, so that works. I hope that was helpful. Let me stop here. I'm trying to reduce the length of my videos and just improve my communication overall. Hopefully, videos that come after this are better. Thank you.